This lesson is on solving systems of nonlinear equations. So most of them will be conic sections. There might be some lines thrown in there too. Lesson one on this will be basic substitution and elimination. First, solve the following system of equations. X squared plus y squared equals 5, x equals y squared minus 3. Now we will solve this one two different ways. First, we're going to solve it with elimination, then we're going to solve it with substitution. I just want to show you that sometimes you can use both methods, and both methods are pretty evenly distributed in terms of their value. So if we want to solve this one by elimination, what we would probably do is subtract y squared from both sides. And then clearly, when you use elimination, like you have in many other systems problems, the y squareds are going to be eliminated. Just be careful. X squared plus x is not 2x or 2x squared or x to the third. X squared plus x, you cannot combine those terms in any other way other than leaving it as x squared plus x. 5 plus negative 3 is 2. Then what we will do is subtract the 2 over, because this is tailor-made for factoring. So x equals negative 2 and x equals 1. Both of those are potential solutions. It's possible that one of them is extraneous. It's possible that both of them work. So we would take those and substitute them back in. We will do the x equals negative 2 case first. So if we take the x equals negative 2 case, let's substitute that back in. You probably want to try both of them just to make sure that it works in both of them. Because if it doesn't work in something, then it doesn't work. But what I will probably do here is I will substitute it back into the first one. So we have negative 2 squared is 4. And again, I'm doing this in the interest of time because I don't want your videos to be forever. So it looks like when we substitute negative 2 back in, we get y equals plus or minus 1. If I substitute it back in to the bottom equation, I would get the same thing. I would get y squared equals 1 after I added 3 to both sides, and then I would take the square root and I'd get y equals plus or minus 1. So negative 2 comma 1 and negative 2 comma negative 1 are both answers that make this work. Next, let's try y or x equals 1, since that was the other thing that we got here. If we substitute that back in, we get 1 plus y squared equals 5, y squared equals 4, y equals plus or minus 2. If I substitute that back into the other equation, I also get both solutions. So that means the values 1, 2, or the points 1, 2, and 1, negative 2 make this work. So I have 4 solutions to this system of equations. Now that's a little bit crazy. Most of the time when we've done systems, we've got one solution. That's because we were dealing with lines before. But now that we're dealing with, in this case, a circle and a parabola, let's think about the potential here for what we have. The potential for a circle and a parabola, we could have no solutions if they don't intersect. We could have one solution if they just barely graze each other. We could have two solutions. We could have three solutions, and I should probably extend the parabola a little bit more. So we could have three solutions if it barely grazes the bottom and then intersects the other two up top. Or we could have, oops, four solutions, which is the case in this particular situation. So uh, let's take a look at that case, and I have Desmos up. We are going to look at the 4 times that this parabola and circle intersect. Okay, so we got the right answers. If you graph things, you can kind of check to make sure it works, and that's that. Now let's move on to solving the exact same thing by substitution. We will not finish solving it. We're just going to get to the point where we get back to where we kind of see what we did on the previous problem. So I can substitute I can substitute this in for x. I mean, I don't think that's the most efficient way of doing this, because then you have to distribute. I mean, you get y to the fourth minus 6y squared plus 9 plus y squared equals 5. You'll be factoring something with y cubed or y squared. It's just really, I mean, you can do it that way, but that's probably not the best way to do a substitution in this problem. What I would do in this particular problem is I would add 3 to both sides. So I get y squared equals x plus 3. And I would just substitute x plus 3 in for y squared. So if I did that in this problem, I get x squared plus, I replace y squared with x plus 3. And now I have x squared plus x plus 3 equals 5. If I subtract the 5 over, I get x squared plus x minus 2 equals 0. And if you notice, this is where it starts being exactly the same as the previous case. So you can just rewind about 2 minutes and then watch me solve the rest of it if you really want to. But you get the exact same solutions either way. Next problem, solve the following system of equations. We have a line and a parabola. Now, a line and a parabola can intersect in the following ways. They can intersect twice, once, or 0 times. So that is something that you have to keep in mind every time you do these problems. You do not want to get more answers than are possible. That's definitely something you don't want to do. In this particular case, you could do elimination, but that would probably take quite a bit of work in terms of getting the y squareds all on the same side. And then you'd have to multiply the bottom equation by 2 or negative 2 in order to get the y's to kind of come about there. So what I would probably do in this case is I would take this and substitute it in for y. So we have x plus 2x squared minus 4x minus 6 equals negative 4. Combine all like terms, we get 2x squared minus 3x minus 2 equals 0. This is also factorable into 2x plus 1 and x minus 2. So our x values that we have to check are x equals negative 1/2 and x equals 2. When we do that, we are going to substitute it in to the equation. I will substitute it into the line for the interest of time. So 2y equals negative 7/2, y equals negative 7/4. So the point negative 1/2, negative 7/4 is on the graph as long as it also works when I substitute negative 1/2 into the bottom equation, which it does. It often does, but sometimes there's occasions where you might get an answer that's extraneous. So you have to be a little bit careful. But negative 1/2, negative 7/4 is an answer here. And then on the other case, y equals negative 3, and that one also works. So 2, negative 3 is another solution. So in this case, we have two solutions where the parabola and line meet. Notice, if you want to make a quick sketch of this, you can solve for y. So y equals negative 1/2 x minus 2. And I don't want to discourage you from making those just because I use Desmos. I mean, you can pretty uh, pretty carefully, or not, I mean, I use a inappropriate, incorrect word there, but you can pretty easily make a quick sketch and kind of see if it's conceivable that there would be two solutions. And if you make a much more detailed graph, you could do this much better. But let's take a look at the second case, and it is clear that those two answers are correct after we graph it on Desmos. Again, you can graph it on your own, but that is something that I just don't want to spend the time doing, given the fact that you should know how to graph a parabola in a line, and I don't want the videos to last too long. The third and final problem that we will do is a system where it's very clear that in this hyperbola and ellipse, we probably want to solve this by elimination. Uh, you could use substitution, but this is tailor-made for it. It's got a negative 2y squared and a positive 2y squared. Just add these things together. So 2x squared equals 12, x squared equals 6. One of the main reasons why I wanted to do this in the basic lesson is I wanted to show you that sometimes you do get some answers that aren't that nice the way that most of you think about nice. So x equals plus or minus the square root of 6. Also, just because we've always solved for x first doesn't mean that you always have to solve for x first. That just so happens in the 3 problems that I picked to do, that was probably the easiest way to go about it. But that doesn't necessarily mean that you always have to do it. So if we substitute root 6 or negative root 6 in, one of the pretty cool things about this problem is you don't even have to do both of them, because root 6 squared is 6 and negative root 6 squared is also 6. So you don't have to spend a whole bunch of time doing that. You can get 2y squared equals 3. And just for the fun of it, because we didn't have to do both things, I can do it in both equations. So 6 plus 2y squared equals 9. I get 2y squared equals 3. So as you can see, in both equations, we're going to get the same value. I'll finish solving one of them. 3 halves equals y squared. Square both sides, or square root both sides. I get root 3 over root 2 equals y. Don't forget the plus or minus. And then most of the time we don't allow radicals in the denominator, so you have to multiply the top and bottom by the square root of 2. So y equals the square root of 6 over 2 plus or minus. Don't forget that plus or minus. So multiply the numerator and denominator by the square root of 2. So remember, this worked in both cases. So we're going to have 4 answers for this problem. Root 6, root 6 over 2, root 6, negative root 6 over 2, negative root 6 over 2, and negative root 6, negative root 6 over 2. Of course, we're going to check on Desmos just to make sure that we're doing this correctly. And if we graph this hyperbola and ellipse, we end up with 4 solutions, which is exactly what we thought would happen. Remember, again, you can graph this on your own. You do not need a computer or a calculator in order to do it. And oh, well, I pressed this button that says I can press this button to stop recording, so that's what I'm going to do.